Before we start, make sure to like and subscribe. 10 species. No antidotes for most of them. Let's go. The fly agaric. Amanita muscaria. The most recognizable mushroom on the planet. The red cap with white spots, the one printed on children's books and decorating Christmas ornaments across Europe. It's not the most dangerous fungus on this list. Not even close. But it opens the catalog because of what it represents. Ibotenic acid and muscimol are its primary toxins. The symptoms are disorientation, hallucinations, muscle twitching, and sedation. It was used ceremonially in Siberian shamanistic traditions for centuries. Deaths are documented but uncommon. What makes it relevant here is the false familiarity. People think they know it. They think the red cap means stop, and then they encounter a pale variant, a sun-faded specimen, a young button stage, and the recognition fails completely. That's how fly agaric puts people in hospitals. The fool's webcap, Cortinarius oriolanus, found across European forests, primarily under oak and pine, and essentially invisible to anyone without specialist knowledge. It looks harmless. Brown cap, rusty gills, ordinary in every visible way. The toxin is arelanine. It's a nephrotoxin, meaning it targets the kidneys specifically and destroys them progressively. What makes it genuinely treacherous is the delay. Symptoms don't appear for 2 to 3 weeks after ingestion. By then, the poisoning has been working for 20 days. The kidneys are already failing. Most victims don't connect what they ate 3 weeks ago to the sudden deterioration they're experiencing now. There is no antidote. Treatment is dialysis and, in serious cases, a kidney transplant. It's caused documented deaths across Poland, France, Germany, and Scandinavia. Slow, quiet, specific. The deadly webcap. Cortinarius rubellus. Same genus as the fool's webcap. Same toxin, arelanine. Same delayed mechanism. But the deadly webcap carries a higher concentration and has a slightly broader European range, pushing further into Scandinavia and mountain forests at elevation. Its cap color shifts from brick red to brown depending on moisture and age. It's been mistaken for chanterelles. It's been mistaken for edible species in the same genus. The delay between ingestion and symptom onset has been recorded as long as 17 days in some documented cases. The kidney damage is cumulative and irreversible beyond a threshold. Both webcap species sit on this list independently, because they represent the same mechanism applied at different intensities, the same evolutionary solution, expressed twice, the panther cap, Amanita pantherina, related to the fly agaric but considerably more dangerous, the same toxins, ibotenic acid and muscimol, but at concentrations 3 to 4 times higher than its more famous relative. Brown cap, white spots, white gills, white ring. It appears in temperate forests throughout Europe, North America, and parts of Asia. What earns it a separate entry is severity. Fly agaric poisoning is rarely fatal in adults. Panther cap poisoning can be. The symptoms escalate faster. Delirium, convulsions, respiratory depression. The confusion it causes with edible species is the central problem. Amanita rubescens, the blusher, is a commonly harvested edible mushroom in Europe. The panther cap mimics it closely enough that experienced foragers have been poisoned. That ove, or lap, is what makes it dangerous rather than obscure. The false morel, Gyromitra esculenta, found in sandy forest soils across the northern hemisphere, appearing in spring alongside the true morel, which is one of the most prized edible fungi in the world. The resemblance is close enough to cause consistent confusion every foraging season. The toxin is gyromitrin, which converts inside the body to monomethylhydrazine, a compound also found in rocket fuel. It destroys red blood cells, damages the liver and kidneys, and in serious doses causes convulsions and coma. Here's the detail that makes it genuinely strange. Gyrometrin is volatile. Boiling the mushroom and discarding the cooking water reduces toxin levels significantly, which is why it's traditionally eaten in some parts of Scandinavia and Eastern Europe. But the margin for error is narrow, and repeated exposure may be cumulative. It's killed people who cooked it correctly. That's not a detail that inspires confidence. The autumn skullcap, Galerina marginata, small, brown, unremarkable. It grows on decaying wood across Europe, North America, and parts of Asia. It produces amatoxins, specifically alpha-amanitin, the same class of toxins found in the death cap. The liver failure mechanism is identical. The difference is that the autumn skullcap is tiny and grows in clusters on logs and stumps in exactly the environments where edible lookalikes grow. Psilocybe species, honey fungus, velvet shank. Foragers hunting edible mushrooms on decaying wood have picked Galerina marginata instead and died. Alpha-amanitin inhibits RNA polymerase II, shutting down protein synthesis in liver cells. The process takes days. Symptoms appear after 6 to 24 hours, disappear briefly while the toxin does its real work, then return as organ failure begins. There's anti-venom treatment with silibinin, but the window is narrow, the destroying angel. Amanita virosa and its close relatives, Amanita bisporigera in North America. Pure white from cap to base. No markings, no pattern, no color. It grows from a vulva buried in forest soil, which means the base is often underground and not visible when picked. The same amatoxins as the autumn skullcap, at significantly higher concentrations. The entire fruiting body is lethal. The cap, the gills, the stipe, the vulva. Cooking destroys nothing. The false recovery period, sometimes called the honeymoon phase, is the clinical detail that defines this species. The patient feels better after the initial gastrointestinal symptoms. The liver is being destroyed during that window. By the time jaundice and organ failure emerge, a liver transplant may be the only option remaining. It's been responsible for a significant portion of all fatal mushroom poisonings in Europe and North America across documented medical history. Podostroma cornudami, a fungus found primarily in Japan and Korea, and visually unlike anything else on this list. Red, finger-shaped fruiting bodies emerging from the ground. It looks almost like a coral or a sea creature. It doesn't look like food. And yet documented poisoning cases exist, primarily from Japan, where it's been mistaken for a medicinal fungus called Ganoderma, which has a different form but is harvested in some regional traditions. The toxins are trichothecene mycotoxins. They cause multiple organ failure, bone marrow destruction, hair loss, peeling skin, and severe neurological symptoms. The clinical picture resembles acute radiation poisoning. It's killed people at extremely small doses. There are very few documented cases, but the toxicity per gram is extreme enough that it occupies a position well above its encounter rate would suggest. The death cap, Amanita phalloides, responsible for approximately 90% of all fatal mushroom poisonings worldwide. That number is not ambiguous. It's been that consistent across decades of toxicological records from Europe, North America, and regions where the species has been accidentally introduced via the root systems of imported trees. It originated in Europe and arrived in North America, Australia, and parts of South America attached to oaks, chestnuts, and other imported hardwoods. It looks like edible mushrooms. Pale greenish-yellow cap, white gills, white stipe. Young specimens resemble puffballs. In parts of East and Southeast Asia, immigrant communities with traditions of harvesting paddy straw mushrooms and Caesar's mushroom have experienced fatal poisonings at higher rates because the visual overlap with culturally familiar species is significant. The amatoxin load in a single cap is enough to kill an adult human, 10 fungi. most of them found in the same forests where edible species grow, sometimes on the same log, sometimes in the same field. The species responsible for the most deaths worldwide looks like at least 3 different things people intentionally harvest. The one with no antidote and no treatment beyond supportive care happens to resemble the most commercially traded wild edible in Europe. That's the pattern this channel keeps landing on across every category. The most dangerous entry on any list is almost never the one that signals danger. Should a topic you'd like us to examine next occur to you, mention it in the comments.